Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. This is problem number 4 in the written answer section of the last exam MLC from fall 2017. For a fully discrete 10-payment whole life insurance of $10,000 on a 35-year-old, you are given the net premium P is 166.58. Mortality follows the illustrative life table. Interest rate is 6%. Write down an expression in terms of P, K40, and interest functions for the present value of future losses random variable at time 5, L sub 5. Part B. Calculate the net premium reserve at time 5. For later parts, this additional information, let the random variable Z denote the present value at time 5 of the future death benefits. Let the random variable Y denote the present value at time 5 of the future net premiums. Part C. Calculate the standard deviation of Z. Show that the standard deviation of Y is 42 to the nearest 1. You should calculate the standard deviation to the nearest 0.1. Part D. Show that the covariance of Y and Z is negative 30,000 to the nearest 1,000. You should calculate the value to the nearest 10. Part E. Calculate the standard deviation of L5. Part F. Explain why the covariance of Y and Z is negative. And here's the solution. For part A, the loss, random variable, is the present value of the death benefit, which for a discrete policy is payable at the end of the year of death, so it's 10,000 times 1.06 to the minus K40 plus 1, minus present value of future premiums, which is payable as an annuity due as long as the person is alive, but no more than 5 years. So it's P a double dot angle minimum of K40 plus 1 and 5 at 6%, because that's the valuation rate given in the problem. For K40 equal to 0, 1, 2, and so on, K40 again is the number of whole years lived. So that's why you have this K40 plus 1 to also include the year in which the person dies in these consideration, because K40 only counts the number of whole years lived, and then the last year of life is the additional one. For part B, the net premium reserve at time 5 per unit of insurance is present value of future benefit. Now this is per unit, so that's why you have A40 as a unit benefit, minus P times A double dot 40 colon angle 5. And we need to establish what these, well, P in this case would be the benefit premium also per unit of insurance, by the way, where we would eventually have to calculate all these for the face amount of this policy, by the way. So the little a double dot is a unit, but we in this very formula, because we use A40, we would use P per unit of insurance, and eventually we'll use the actual net premium in the policy when we do it for for this policy. So it will be 10,000 times the unit, the reserve per unit. But anyway, we need a double dot 40 colon angle 5, which is equal to a double dot 40 minus 5E40, the 5-year actuarial discount factor, accounting for both interest and mortality, times a double dot 45. And all of these values are in the illustrative life table, so we plug them in and we get 4.44011. And A40, big A40, per unit is 0.16132. Now in the table it's actually 1000 times A40 is given, but it's okay, you can easily translate it to this. And then the total net premium policy reserve is for 10,000 of face amount, that's why it's 10,000 times 5V, and that's 1,613.20, that's 10,000 times 0.16132, minus the premium that is given as 166.58 times 4.44011, the annuity factor that we found. And then the value is 873.57. For part C, the present value of death benefit is 10,000 times 1.06 to the minus K40 plus 1, the whole quantity, with a minus sign in front, for K40 being the number of whole years lived. And therefore the variance of Z is 10,000 squared times the variance per unit of life insurance on a 40-year-old, which is A40 minus A40 squared, and then 2A40 and A40 are in the table. We just get them from the table and plug it in here, and we end up with a value of 2,260,595.76. The standard deviation of Z is the square root of this variance, approximately 1,503.52. For the second part, define the random variable y to be p times 1 minus z2 over d, where d is, of course, the discount rate of discount corresponding to the 6% that we're using, which would be, of course, 0.06 divided by 1.06. And z2 is equal to 1.06 to the minus k40 plus 1 for k40 equal to 0, 1, 2, 3, or 4. But then starting after the 5th year, it will be just 1.06 to the minus 5. So we're introducing this new random variable. And it's equal to 1.06 times to the power minus minimum of k40 plus 1 and 5. And of course, d is what I said. So then the variance of y, because the premium is paid over 5 years, that's going to be p over d squared times the variance of unit 5-year endowment policy. I mean, common that it's 5 years because that's how many years are remaining of the payments. It's a 10-pay policy, but we're in the 5th year. So furthermore, we have that E of Z2 is a 40 colon angle 5, and then we write this as a 40 colon angle 5 with 1 above the 40 indicating term coverage plus pure endowment of after 5 years. Then this term insurance single net premium can be written as A40 minus 5E40 times A45. And the reason why we do this is because all of these terms are in the illustrative life table. Then combine the terms that have 5E40 in them, and you get A40 plus 5E40 times 1 minus A45. And then all of these values are in the illustrative life table. We plug them in, we do the calculation, we get 0.748675. I'm sorry, 0.74867. And what is E of Z2 squared? The second moment. Well, because the benefits of this unit insurance are either 0 or 1, it's the original plan of insurance, but under the force of interest of 2 delta, which we write as 2 in front of a 40 colon angle 5. And then we write this as separately term insurance with double the force of interest, plus pure endowment under the double of force of interest. But if you just write 5E40, then that has only 1.06 to the negative 5, which is the same as e to the minus delta to the fifth, or e to the minus 5 delta. If you want to double the force of interest, you need to write there e to the minus 10 delta, or 5 times 2 delta, which is e to the minus 10 delta. Well, if you separate it into e to the minus 5 delta times e to the minus 5 delta, one of them taken to the probability of survival makes this 5E40, and the other one is left to the left, not behind really. Then e to the minus 5 delta is the same as 1.06 to the minus 5. Of course, delta is the force of interest equivalent to the 6% effective annual rate. And now we write the term insurance as 2A40 minus deferred by 5 years, but under the double of force of interest. So again, 1.06 to the negative fifth times 5E40 and times 2A45 from that we can get from the illustrative life table, plus that 1.06 to the negative 5 times 5E40. Now combine the terms that have in them 5E40, and you end up with 1.06 to the negative 5 times 5E40 times 1 minus 2A45, and then of course 2A40 in front. Those terms are all now in the illustrative life table, so we plug them in and we get approximately 0.5607078. And the variance of y is therefore the premium divided by d squared times the second moment minus the square of the first moment. And that's 1745.361, and the standard deviation is the square root of that, approximately 4178. Well, we have that covariance of z and y is minus p over d times covariance of z and z2, because of y being p times 1 minus z2 over d, and covariance of z and z2, of course, is by definition e of z times z2 minus e of z times e of z2. Then we note that z times z2 is 1.06 to the minus 2 times k40 plus 1 for k between 0 and 4, k40 between 0 and 4, and then it's 1.06 to the negative 5 times 1.06 to the minus k40 plus 1 for k40 equal to 5, 6 or more. Therefore, e of z times z2 is, for the first case, is 2a 40 colon angle 5 with 1 above the 40 for 5-year term, plus deferred 5 years, whole life, but multiplied by 1.06 to the negative 5. And then we can write 2a 40 colon angle 5 1 as 2a 40 minus 1.06 to the negative 5 times 5e40 times 2a45, and all of these are in the illustrative life table. We'll plug them in, plus that 1.06 to the negative 5 from the front times 5e40 times a45, and both of these are in the table. We plug it all in, we get approximately 0.1218059. Well, we conclude that covariance of z and y is minus p over d times 2a 40 colon angle 5 1 plus 1.06 to the minus 5 times 2 times deferred by 5 years A40 minus A40 times A40 colon angle 5. And then we have all of these values from previous calculations. We plug them all in, and we obtain negative 30,328.41. And that's the end of part D. For part E, we have L5 equal to Z minus Y, where Z is 10,000 times 1.06 to the minus K40 plus 1, for K equals 0, 1, 2, and so on. And Y is equal to P times 1 minus Z2 over D, where Z2 is, again, defined as this 5-year endowment policy, well, present value of the death benefit for this 5-year endowment policy. Therefore, the variance of L5 is the variance of Z plus variance of Y minus 2 covariances of Z and Y, and that's 10,000 squared times 2A40 minus A40 squared plus P over D squared times 2A40 colon angle 5 minus A40 colon angle 5 squared minus 2 times P over D times the whole expression of 2A40 colon angle 5 1 plus 1.06 to the negative 5 times 5 divided by 5 years A40 minus A40 times A40 colon angle 5. We plug in all the numbers we actually calculated. So we plug in what we calculated. And note that the covariance we calculated was negative, so now multiplied by this negative number here becomes positive. And so the variance of L5 is 2,322.988. The standard deviation is the square root of that, approximately 1,524.14. For part F, Z and Y move in opposite directions as a function of length of life of the person insured. An early death causes a relatively bigger value of Z, because you paid money earlier for death benefit, and a relatively smaller value of Y, because you paid an annuity for a shorter period of time. And a death at an older age implies a relatively smaller value of Z, because the death is later, so its present value is smaller. Present value of the death benefit is smaller, and a relatively larger value of Y because the annuity is paid over a longer period of time. This implies that Z and Y are negatively correlated. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.